In this video, we're going to look at three applications working with our quadratic function. The first one here, we have an example. It says we want to write the standard form. So we know the standard form here is y equals, when it says standard form, we know that's y equals a times x minus h squared plus k. So we want the standard form of the equation of the parabola that has a vertex 5, 12. Well, if that's the vertex, we know that is our h and our k, that's the vertex, and passes through a point 7, 15. So that's just an xy point that falls on the parabola. So for example, if our parabola has a vertex of 5, 12, then here's our vertex 5, 12, which would be h and k. And then we know that it has some other point at 715, which would be over here somewhere. And that's just an xy coordinate for 715, some other point that falls on the parabola. So we want to find, given this point of 715 and the vertex here of 512, we want to find the equation that represents this parabola. Well, if you look closely at our standard form, y equals a, x minus h squared plus k. Well, if we have this as our formula, what do we need to know? Well, to come up with the equation, we need to know, first of all, a, we need to know h, and we need to know k. Well, we already know h, we already know k, so we're good there. We know h is 5, and we know that k is equal to 12. So the only thing that we have left to find is a. And remember, a is going to cause either kind of a vertical stretch or vertical shrink. And if it's positive, our parabola is going to open up. If it's negative, it's going to open down. So how can we find a? Well, we also know from this formula, we have x and y. Well, x and y is just as representing a point on the parabola. Well, we have that. That would be our 7 and 15. So y is equal to 15 and x is equal to 7. So if we substitute in all these values, then we can solve for a. So that's what we want to do here. We're going to substitute in for each variable. So if we do that, we would end up with 15 equals a times x, which is 7 minus h, which is 5, quantity squared, plus our 12. All right, so then we're going to just simply solve for a. So we would take 7 minus 5, which is 2, so that's squared, plus 12. And then we would take 2 squared is 4, so I'm going to write this as 4 times a. And then we need to get that 4a by itself, so we're going to subtract 12 from both sides. So 15 minus 12 would be 3. So 3 is equal to 4a. And then to simply divide by 4, so therefore a is equal to 3/4. So now all we have to do is write the equation. Well, we know the equation then is going to be y equals a, which is 3/4, times x minus h, which is 5, and that's going to be x minus 5 squared, plus our k, which is 12. Now keep in mind, when you go to substitute this back in to find the equation here, realize we're not going to substitute in the y and x variable. We don't want to plug 15 and 7 in because otherwise then we just end up again with two numbers equal to each other. We want the equation. So x and y is what's given us the equation. X and y is representing all of the points that fall on this parabola that will satisfy this equation. All right, so there's the first example. Our second example says we want to find two positive real numbers, okay, two positive real numbers whose product, and product means we're multiplying, is a maximum. and it tells us the sum is 130, which means the sum of the two numbers is going to equal to 130. So we want to find two positive real numbers whose product is maximal. So if we want, what we want to do is maximize, we want to maximize the product. So the product is going to be equal to two numbers, and I'm just going to say the two numbers are x times y, and you can use any letter you want here. I'm using x and y. You could use a and b or d and e or whatever you want. So the product of our two numbers, one number's x, one number's y, so x times y is equal to some value p. And we're trying to find what two numbers that will add up to 130, and when we multiply them together, they will give us the maximum product, the largest number. Now, we could certainly just go through trial and error and try to work this out, picking numbers that add up to 130, multiplying them together, and finding out what's going to give us the largest value. But we want to set up some equations to make it a little bit easier. Well, they tell us that the sum of the two numbers is 130. So that means that if we take one number, x, plus the second number, y, the sum is going to equal to 130. Well, now we can simply solve for either variable. Well, it doesn't matter. I'm going to solve for y, so that means we need to subtract x. So we would have 130 minus x. Now, the reason we solve this for y, now we can take this value 130 minus x and substitute that in over here in place of the y. So when we do that, we have p equals x times y. Well, instead of y, we're going to write 130 minus x because we know 130 minus x is equal to our y. Now, what was the advantage? Well, now the advantage of this is we've eliminated one of the variables up here. So now if we distribute this, distribute the x, we would get 130x minus x squared. Now, I like to rewrite this in order. Notice we have our 130x minus the x squared. I'm going to write the x squared term first. Now, be careful. This is minus x squared, so this negative sign goes with the x squared. So we would have a negative x squared, so that remains negative, and the 130 is positive, so that's plus 130x. Now, I think this way it looks a little bit nicer. Now, keep in mind, there's nothing added on here. You could think of this as plus 0. There's nothing added. Normally, you think of a quadratic equation. We have your x squared term, your x, and then your constant term. And keep in mind, this is really like, what, ax squared plus bx plus c, where a is a negative 1, b is 130, and c is equal to 0. Now, what do we want to find? Let's go back to the problem. We want to find two positive real numbers whose product is maximum. So we want to find a maximum value. Well, hopefully by now we realize that if we were to graph this, p equals, now again, p, this is the p value, we can think of that as y. Y equals a negative x squared plus 130x. We know the graph is going to be a parabola, and our a value is negative, so we know this is going to be a parabola that opens down. So if we're trying to find the maximum value, that means we're looking for the vertex here. That's going to give us the maximum value. And we know the vertex, we're looking for h, and also we can look for k. Now, in this problem, we're using h and k as representing our vertex. Now over here, what are the variables that we're using? Well, in this case, we have x squared plus 130x. So this would be kind of like our x. And instead of our y value here, if we look at our equation, instead of y, we're using the letter p. So this is really x and p. So what we really want to find is the x. Now, if you remember, I gave you a formula before that we can easily find the vertex. And that formula is if we're looking for h, which in this case that would also be here the x value. If we're looking for h, then that is negative b divided by 2a. So if we take a negative b, that's going to be a negative 130 divided by 2 times a, which is a negative 1. So therefore, h is equal to a negative 130 divided by a negative 2. Well, divided by a negative is going to give us a positive 65. So over here, we know that we're going to have 65 as our h. Okay. Now, for this problem, we really don't care about the p-value. We have this other value here for p, but we'll come back and talk about that in just a little bit here for this p coordinate. So we know h is equal to 65, which for us, we know that's really our x, okay? Because up here we had our variable is x. Now we want to take this. This is going to be one of our numbers that's going to give us the maximum product. But we want to take this number and substitute that in up here for our x to find our y value. So if we do that, we're going to end up with y equals 130 minus 65. So that means 130 minus 65 is equal to 65. So there is our other number. Because remember, up here, x and y was representing our two numbers. So x was one number, y is the other number. So the two numbers that add up to 130 is, first one is 65, the other one is 65. And then if you multiply them together, that's going to give us the maximum value. So the answer here would be 65 is one number and 65 is the other number. Now, if we go back and we want to figure out what is this value here representing with the parabola. Now, you have to realize here we're looking at two different equations. X plus y equals 130. We're looking for one number x, another number y. So we found out that's 65 plus 65. Well, over here, we have p equals x times y. So if you multiply 65 times 65, what does that equal? Well, 65 times 65 is equal to 4,225. So that is this value here, 4,225. So that would be the y coordinate, or the k, for our vertex. So the vertex here, if we were to graph this negative x squared plus 130x in the calculator, your vertex would be 65 for the x value and 4,225 for the y value for the vertex. So don't get too confused here. I know you're using x and y here a little differently, but keep in mind here this vertex, the x and y value, which is the h and k, is 65, 4,225. And when we look at the equation here, x plus y equals 130, x is 65, and y, which is our second number, is also 65. All right, our next example says we want to find two positive real numbers whose product is maximum. So that's the same thing as we had before. But now they tell us the sum of the first and twice the second is 24. So we want to kind of start off the same way. We're looking for, up here, the product is maximum. So product of two numbers, we can still say product is equal to xy. So we can say we're looking for the product where we have product is equal to x times y. And once again, we're looking how we can maximize this. But now it says the sum of the first and twice the second equals 24. So if I let x, label that as my first number, we can label y as our second number. That may be helpful for you. So it's saying if we take the first number, which is x, and we add it because it says the sum to the second number, but it says twice the second. So if we're looking at twice the second, that means we're looking at 2 times y, and that's equal to 24. So now we're going to do basically the same thing. If we compare this to the previous example, the only difference up here was it said strictly the sum is 130. So all we had to do is take x plus y equals 130, and we solved for y. Now we could have solved up here for x. It doesn't matter. So down here we have the same situation. We want to solve for x or y, and then we want to substitute over here into p equals xy. Now, which is easier to solve for? Well, if we try to solve this equation for y, then eventually, once we move the x over, we would have to divide by 2. Well, to make this easier, I'm going to solve the equation for x, because if we solve for x, all we have to do is subtract away the 2y. So we get x equals 24 minus 2y. So once again, we're going to take the 24 minus 2y, and we're going to substitute that in over here in place of our x. So then we're going to end up with p equals x, which is the 24 minus 2y. So we take 24 minus 2y multiplied by y. And then we simply distribute. So now again, we did the substitution. So now we only have one variable. So I'm going to distribute the y. And once we do that, we would have 24y minus 2y squared. And just like I did before, I want the y squared term first. So I'm going to simply move that out front. So it's a negative 2y squared. And then we have our positive 24y. And again, we want to find the maximum. Well, from this equation, once again, here we have this is our A, this is our B, and C is equal to 0. Well, because the A value here is a negative, negative 2, once again, we know our parabola is going to open down. And again, we're trying to find the vertex here. This is our maximum point, which is the vertex. So that is our H and our K. And in relation to our equation over here, the variables would be Y and P. Okay, so we want to find our H. Well, our H, remember, is simply going to be negative B over 2A. So we're going to find H by taking a negative B, so that's a negative 24 divided by 2 times A, which is a negative 2. And we're going to end up with a negative 24 divided by 2 times negative 2 is a negative 4. So negative 24 divided by negative 4 makes it a positive 6. So that is our H value. So over here, that is equal to 6. Now, keep in mind, up here, our variable here for this is really what? This is really our y variable. Now, this is don't confuse this. This is a y variable, which is our h. Now, in relationship to this vertex, that is still our x coordinate, but we just happen to use the variable y for this particular problem. So up here where this says p equals a negative 2y squared plus 24y, the reason we have the variable listed here as y is because up here we solve this equation for x equals 24 minus 2y. So be careful and realize that the parabola, the quadratic equation that we have for the parabola here is p equals negative 2y squared plus 24y. So in terms of our coordinate, the y is like our x, like I've written over here, and the p is like our y value. So as far as the coordinates, the y is the x coordinate, the p is the y coordinate. Now, once again, for this problem, we're not really concerned with this coordinate here because we know that if h is equal to 6, that is a y value. We want to take and substitute this y value, which is 6, back into this equation here. So we have x equals 24 minus 2y. Now, why are we doing this again? Because we're looking for X is our first number, Y is the second. Well, we know Y is already equal to 6, so we want to substitute that in. So we get X equals 24 minus 2 times 6. So X is equal to 24 minus 12. So X is equal to 12. So if we go back up here, our first number, we can say then X is 12, and Y, which is our second number, down here, we found that to be 6. Now, let's see if this works out. It says the sum of the first and twice the second is 24. So the sum of the first, that's 12, and twice the second, so 2 times 6 is 12. So 12 plus 12 does equal 24. And what we're saying is if we multiply the 6 and 12 together, what does that equal? Well, 6 times 12 is going to give you the maximum product, and 6 times 12 is equal to 72. So that's what the 72 here is representing in relationship to this parabola. 72 is the maximum value. So what we're really saying is when our y here for this, our number is 6, then our maximum product is going to be 72. So our two numbers then turn out to be 6 and 12. That's the two numbers that we're looking for. All right, so hopefully now looking at these three examples, you're able to work out the next set of practice problems.